All right, welcome back, ladies and gentlemen. This is our continuing lecture on collisions, but now we're going to go to elastic collisions. Now, remember on the last lecture, we talked about three types of collisions. There's elastic and inelastic, but in reality, they're perfectly elastic, perfectly inelastic, which never really happens. We usually just end up having a combination. Okay, so the key to an elastic collision is when it hits and bounces off each other. And that's really where we're going to talk about, and we're going to talk about a perfectly elastic collision. All right, in a perfectly elastic collision, okay, we're going to conserve both kinetic energy and momentum. We're going to conserve both kinetic energy and momentum. So if we know that M1 V1 initial plus M2 V2 initial, let's say two balls, and we're going to do some examples here in a minute, and that's going to equal to M1 V1 final plus M2 V2 final. Conservation of momentum, okay? And now kinetic energy, 1/2 M1 V initial squared plus 1/2 M2 V2 final squared is equal to 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. All right, so this is just conservation of kinetic energy. Now, you guys, if you want to wait and not copy this down, it's fine, because we're going to take these two and combine them. And when we combine them, okay, we're going to end up with what looks like a really complicated equation. And it kind of is, but when you start to use it, it's pretty easy, particularly if the masses of each ball are the same. If the masses of each ball are the same, then it makes things super easy, as we will see. Okay. Now, when we have this, when we combine these two equations, okay, we can say the final velocity of the first ball, is going to equal to the difference between mass 1 and mass 2. So M1 minus M2 times the sum M1 plus M2 times the initial velocity of the first ball, plus 2 times M2 divided by M1 plus M2 times the initial velocity of the second ball. You guys, does that look pretty complicated? I agree. It does look complicated, but we will see that it's much easier in practice than it looks like. All right, so the second velocity, the second final velocity of this ball, which would be this and this, is going to equal to something similar. It's going to be 2 times the first mass divided by M1 plus M2 times the initial velocity of the first ball, plus M2 minus M1 over M1 plus M2 times the initial velocity of the second ball. Okay, again, you guys, it looks really complicated, okay, but we will see that it is not so bad. All right, so I'm going to give you guys a chance to do that. We're going to slide the board over, and then I am going to do a couple of examples, essentially the same example that we had before, except when they hit, they're not going to stick, they're going to bounce off, okay? Part of this is going to be intuitive, all right? You guys got all that written down? All right, so now let's go back to this. All right, so we're going to come right here, and And again, we're going to have, let's say, a 1 kilogram ball, okay, that's got initial velocity of 6 meters per second. And that is going to hit a 1 kilogram ball with an initial velocity of 0. Okay, so this is our before. And now our after. Okay, so you guys, what do you suppose is going to happen when they hit and bounce? When they hit and bounce. Okay. What do you guys think that the final velocity of the black ball is going to be after it hits the green ball? So black ball cruising on at 6 meters per second. It's going to hit the green ball that's going at 0. What's going to happen to the velocity of the black ball after it hits?
Is it going to go to 0?
It is going to go to 0. Okay. You guys might have seen this kind of firsthand if you've played any pool or billiards. And if you notice in a billiards game, sometimes when one ball is going to hit the other ball straight on, okay, the first ball stops and the second ball continues. Okay, so that's going to be what happens. All right. So you guys, let's take a look and we'll put in the numbers. We'll put in the numbers for these equations over here. Okay. So I'm going to kind of just take this first equation and just put the numbers in here. So our final velocity of the first ball is going to be the difference, which is going to be 1 minus 1, the difference in the masses divided by the sum of the masses, times 6, plus 2 times 1 divided by 1 plus 1 times the initial velocity of the second ball, which we know is 0. Okay, now, you guys, we can see because the second ball had an initial velocity of 0, this whole part is going to go away, right? Because we multiply anything times 0, it's just going to go away. You guys, what is 1 minus 1? Obviously 0. So this is all going to go away as well. This is all going to go away as well. So this is going to be 0 plus 0. So that shows us, you guys, that our velocity of the first ball is going to go to 0. Our velocity of the ball is going to go to 0. So now let's take a look at the second ball, okay? We're going to have V2 final. Okay, so now we won't be able to see the equation, but it's going to be this one right here, okay? So now we are going to say, okay, that it's going to be 2 times the first ball. So 2 times 1 divided by 1 plus 1 times the initial velocity of 6 plus 1 minus 1 over 1 plus 1 times 0. Now again, we look over here, this part is going to drop out. This part is going to drop out. So now we're going to have 2 times 1 is 2 divided by 1 plus 1, which is 2. 2 divided by 2 is 1. 1 times 6 is 6. So this goes away. This part is 6. So what's going to happen to the green ball is after the black ball hits it, the black ball is going to stop and the green ball is going to go at 6 meters per second. At 6 meters per second. Okay, you guys, that's with the math there. But if we just think about conservation of momentum, okay, if this one's cruising along at 6 meters per second and it hits and stops, due to conservation of momentum, this second ball is going to continue with the velocity that the first one had. The velocity that the first one had. Okay, so what's going to happen, this 6 stops, this one was 0 and goes to 6. Easy peasy. Okay, now, you guys, what if this one, the second ball, was, let's say, -2? -2 instead of 0. So they're kind of coming in a collision course. Now, you guys, we could put these numbers. We could put these numbers in there. We could put those numbers in there, but it's probably easier because their masses are the same to just think about what it would be based on what we just talked about. Okay, so this one is going to be 6. It hits this one. This green one is going to go to the right at 6. The green one is going at -2. It's going to hit the black one, and the black one's going to go back at -2. They're just going to exchange their velocities. They're just going to exchange their velocities, which is the beauty of conservation of momentum. Okay, well, what if this one was +2? Now, they're going to collide because the first ball, the black ball, is going faster. It's going faster than the second ball. So when it catches up and they collide, okay, what do you suppose the velocity of the green ball is going to become? And the answer is it's going to become the velocity of the first ball, the black ball. So this one's going to be 6. And what do you suppose the velocity of the black ball is going to become? And it is going to become +2. Okay, so again, they are just exchanging. They're just exchanging their velocities. Okay, so what we really need this equation for, is if we have different masses. If we have different masses, and those different masses will play into what happens to the velocity of the balls, and that is where it starts to become a little less intuitive. It's kind of harder to figure out. So you guys, let's go back for this one last example. We're going to say this initial velocity is 0, but now we're going to say it's 2 kilograms. We're going to say it's 2 kilograms. Okay, so now if we plug in our numbers, if we plug in these numbers up here, okay, the only difference is that it's going to be 1 minus 2 divided by 1 plus 2. And again, since this ball started at 0, this part's just going to go away. Okay, you guys, what's 1 minus 2? -1. What's -1 divided by 3? -1/3. What's -1/3 times 6? -2. Okay, so what happens, since this green ball is heavier, more massive than the black ball, this black ball is going to hit, and it's actually going to bounce back a little bit, okay? And it's going to be going at -2. Well, what's going to happen, you guys, what's going to happen to the second ball? And I'll kind of change colors here. So now we're going to have 2 times the first ball plus the sum, which would be 1 times 2. And again, since this first ball had an initial velocity of 0, it's going to go away. So now we're going to have 2 times 1 divided by 1 plus 2, which is 2/3. So this one's going to be 2/3 of 6. So then this final velocity is going to be +4. It's going to be +4. All right, so again, even though we have this sort of complicated equation, the only time that we really need it is when we have masses that are different, okay? And when you have masses that are different, then you can plug that in. So if the masses are the same, and a lot of the quiz questions that you're going to see in the future, the masses are going to be the same, and all they're going to do is exchange their velocities when they collide, okay? All right, you guys, that was a little bit shorter, but we're going to see more examples of that. All right.